All right, today we're going to talk about a really important concept, actually two little important concepts. The concept of domain and range of a function. Domain and range. Domain is inputs and range is outputs. Domain is x's and range is y. Domain is x, range is y. Domain is input, range is output. And depending on how we're looking at the function, we might think of any of those different things. Domain and range, big idea here. Okay, this is a big takeaway. What I'm going to do to answer this, let's answer the first question. Consider the function y equals f of x shown on the graph. So there's our curve, that's our function. It says evaluate each of the following. F of negative 3. So what I want to do is go again over to 3, negative 3 in the x direction, and then look up. There's my output. My output is 1. If I go to 1 in the x direction and look down, my output is negative 3. If I go to 3 as an input, 1, 2, 3, 3 in the x direction, 1, 2, 3, 4, 5 is my output. Okay, we can read that. We've been doing that for a few days now. Next question says, can the function rule given by the graph give you a value when x equals 5? Well, let's take a look at this graph. When x equals 5, 1, 2, 3, 4, 5. There's no point on that graph. Okay? So we say no, there is no value when x equals 5. Why not? Because the graph doesn't extend to when x equals 5. So what we say is, the question here is x equals 5 in the domain of the function? No, it's not. Domains are all of the inputs that we put into a function. And the range is kind of the y values that we get out of that function. Question D says, give two other values of x that are not in the domain of the function. Well, let's see. 5 is not, 6 is not, 7 is not. Any of those x's where there's not a point would be not be in the domain. Or if I went to negative 1, 2, 3, 4, 5, negative 6, not in the domain, negative 7, negative 8, negative 9. Even if I went to 1, 2, 3, 1, 2, 3 and a half. 3 and a half is not in the domain. Because that graph, the function, doesn't go through that point in the x direction. Here's one way we can think about domain and range. If I put kind of a box around this function, so I'm going to just kind of sketch a little box that totally encloses this function. There's a box. My domain goes from here to here. In the x direction, my domain goes from here to here. My range goes from here to here. So when we talk domain, we talk left to right. When we talk range, we talk bottom to top. Okay? Part E says, circle the following values that are in the range of the function. Well, the range, again, goes from here to here, from lowest point to highest point. Y equals 0, is that in the range? Well, that's right here, so yes. Y equals 6, 1, 2, 3, 4, 5, 6 is up here. No, that's not in the range. Y equals negative 1, yeah, that's there. That's in the range. Y equals 3, 1, 2, 3, yeah, that's in the range. Y equals negative 5, 1, 2, 3, 4, no, that's down here. That's not in the range. And y equals 4, 1, 2, 3, 4, yes, that is in the range. Okay, so domain, again, goes left to right, and range goes bottom to top, lowest point to highest point. What we want to do in this next question, this is kind of the important takeaway here, is can we write the domain and the range using a single inequality? So again, let's think about the domain. The domain goes left to right from here to here. The leftmost point it hits is negative 1, 2, 3, 4, 5. So from negative 5 to positive 3, all of the x's that are in between there. And we are going to include negative 5, and we are going to include 3 this time, because the graph looks like it goes through those points. Okay? If there was an open circle at the end, we might do a less than or a greater than. Okay, but this one looks like it goes through those points. The range, again, is the y values, the lowest to highest y value. The lowest y value we reach is at this -4, and the highest is at 5. So I would write the range, again, least to greatest, so -4 to 5. Now the difference here is we're used to seeing x there, but range is actually a y value. So I would say -4 is less than or equal to y, which is less than or equal to 5. Domain is the inputs, or the x values. Range is the outputs, or the y values. Now that last example was using a graph. We could use an equation to figure out range as well if we're given a domain. So let's see. Here's our function. Our function is x divided by 2 minus 3. And we're given 3 values in the domain. What we want to do is come up with what values are in the range. So let's see, if x is -4, -4 divided by -2 would be -2 minus 3 would be -5. If x is 6, 6 divided by 2 is 3, minus 3 would be 0. So the inputs, again, are the domains, the outputs are the range. If x is 10, 10 divided by 2 is 5, minus 3 is 2. So the domain, it says here, write the set in roster notation. Roster just means a list, and we usually write them in a little bracket. The domain would be -4, 6, and 10. And I'll label that with a D. The range would be 5, 0, and 3. And notice that the order didn't matter there. I put 5, 0, 3 instead of 0, 3, 5. It doesn't matter with a set of numbers. It's just kind of a collection of things. The order does not matter. So this next question, exercise 3, says, which of the following values is not in the domain of this function? Illustrate your thinking by marking points on the graph. And again, we can mark up this graph. This graph, when we're talking domain, we're talking the x values left to right. So let's see, this graph starts here and it ends here. So it goes from -5 up to 1, 2, 3, 4. I think 1, 2, 3, 4, if I counted that right. So from -5 to 4, those values are in the domain. Which of those values are outside the domain? Well, -3 is in there, -4. 5 is not in the domain. 5 would be after that graph has stopped. Okay, so 5 would be our correct answer here because, again, the question was asking which of those values is not in the domain. And sometimes, again, it helps to draw like a box around the function or kind of horizontal or vertical lines to mark off the domain and the range. Exercise 4 asks us about another one of these piecewise linear functions. So I'm going to work through this. This is going to take a couple of minutes, and then we'll determine the domain, determine the range. So we don't know the range of this function. We do know the domain because they tell us. They tell us only to graph this function between when x is -4 and 2, and then between when x is 2 and +4. Okay, so that's our domain. And we're going to figure out the range by making a table of values. And again, when I make this table of values, I'm going to make 2 columns. I'll call them x and y, or x and f of x. F of x and y mean the same thing. And I'm going to plug in values for x and y. Now again, it's told me here what values to put in for x. There's a breaking point here for this function when x is 2. So when x is 2, something happens and this function splits into a different thing. So what I'm going to do is go to my table, just draw a line here at 2. And now I'm going to calculate each of those things. So when x is between -4 and 2, I'm going to evaluate negative parentheses x plus 2 and then divided by 2. And when x is between 2 and 4, I'm going to evaluate 4x minus 10. And I'm hoping that at 2, both of those values turn out to be the same thing. I'm going to check that as well. So let me fill out my table, you do yours, and let's check to see they mean the same thing. And then I'm going to graph them, and we'll determine the range. And let me do this first point with you. So the question is, what is the output when x is -4? So that would be the opposite of -4 plus 2, all divided by 2. -4 plus 2 inside the parentheses would be -2, so the opposite of -2 divided by 2. That's +2 divided by 2. My output for that first value will be 1. All right, hit pause and figure out the rest of those values. Check them with mine, and I'm going to plot them on the graph as well. Okay, so take a couple minutes, do those calculations, and see if they match with mine, and then plot the points. Then we'll figure out the range. Okay, so I've plotted these points on the line, and it looks like for me it went like this, and then all of a sudden it took a sharp turn and went like this. So check your math there. The question for this one is determine the function's range. And again, range is lowest to highest. So what I'm going to do is just check here. The lowest value I reach, the highest value I reach. The lowest value I reached was -2, and the highest was 6. So I would write the range of this function as -2 to 6 with y in the middle. So -2 less than or equal to y, which is less than or equal to 6. All right, so pretty early concept here. We haven't dealt with this before. We're just touching on it. We'll talk more about it, but domain is input, range is output. Okay, so try those homework questions. And again, put a big circle around the ones you don't understand. And that's it for today. Good job today, guys. Bye.